Hi, I'm Jesse from Circuit Analysis, and I'm going to go over a good tool to analyze power electronics by the name of SIMPLIS SIMPLIS. And here's the website. It's by a company, SIMEtrix Technologies, and you can download their free demo, which has full functionality. It just limits the number of nodes and circuit elements you can use. And it has some of the features like their scripting language disabled. So here it is. You can switch between SIMEtrix and SIMPLIS mode by going to the simulator and switch to SIMPLIS, switch back to SIMEtrix. And SIMEtrix is a standard SPICE solver, so it's like piecewise or Berkeley SPICE or LT SPICE, whereas SIMPLIS is a piecewise linear circuit analysis tool. So instead of using SPICE component models, SIMPLIS uses only the piecewise linear approximations of those models, and that helps with convergence and speeds up simulation time for circuits that are very discontinuous, like switching power supplies. So we'll start off in SIMEtrix mode, which is the standard piecewise mode, and we'll draw a simple voltage divider. So now there's three ways to add components. There's this toolbar up here where you can add them, these ones quickly, or you can go to place and add components here like passive, capacitor, resistor, or you can go to View, Show Part Selector, which gives you this bar over here where you can select parts. So we're just going to use the top here, and we'll put, you can just keep clicking to add components and then escape to stop adding them, and then we can get this voltage supply. And now to connect them, we could use this pencil tool here to draw wires, but it will automatically switch to the pencil if you hover over a node. So you just click once, then you click to add your wire, and then once you're done, you right click, and then it stops. So left click, right click. And now the only other thing we have to add for this to work is a ground node. So SPICE needs a ground node. So there's our circuit. Now SIMEtrix comes standard with a setting that you're going to want to change. So now I can double click on these components to change them. So I can make this 2K in here, but there's no way to change the reference designator, and I can't click on these here. So what you need to do is go File, Options, General, then you have to click this box, Enable GUI Property Edits, and then now you can click on these. So you can change the value by clicking on that, or you can change this here. To a different reference designator. Now we need to set up the simulation, so we can go to Simulator, choose Analysis, and you see across the top here all the different tabs with the analysis options you can set up, and then here are the check boxes of which analyses you want to run right now. So if you go over here, like Options, this gives you the solver options to set your temperature and your different tolerances to help with convergence. So we'll just leave that standard, and we'll put in the transient 1 millisecond, and we'll check this box to enable transient analysis. And now we're going to put a probe in. So you can either just click a probe once, or you can place a fixed probe. We'll do a fixed voltage probe here. And now, when we run the analysis, we can either go up here to Simulator, Run Schematic, shortcut F9, or we can click on this play button here. And we're getting this error, missing nodes, device has 2 terminals, and that is just because when I was renaming this, I accidentally put this extra new line after it, and it made this little error. So if we fix that, we run it again, Now we see here's the simulation, you close that, and then it's put up a new window here with our voltage here. So we have 1 millisecond here, and then we have our voltage here, which is 1/3 of 5 volts. Now this waveform viewer is kind of cool because by default you can overlay waveforms on top of each other, which is pretty much impossible with piecewise. But so I can change this to 1K and just rerun, and you'll see it just put another line on there. And then if you want to add another waveform, we could get the 5 volts too, just with this little probe button up here. Now we have those 3 waveforms. So now we can save our file by going to File, Save Schematic As. So I saved mine to this folder, and you can see there's 2 files. There's this locked file that tells you who has the file open, and then this is the main schematic file so far. And if you look at this, you can open it and it's just text. So that's a nice thing. You can see all of the settings and everything in the file. And now if we run the simulation again, see it puts up a new page here. Now there's 2 tabs. And if I go back to the folder, there's 2 more files. So there's this .net and this .out file, and those are both text files too. So you can see what's in those. And the net file is just the net list, which just is regular SPICE, it shows the components. And you can also open this file by going to the schematic. One thing to note is when you click over on this, it changes the menus. So you click over here, you can go Simulator, and then you can go View and Edit Netlist, and that brings up that same file we were just looking at. Now what we didn't see is the file that holds all the simulation data. So to see that one, we can close this guy out and go back to the schematic, and then we can go Simulator, Manage Data Groups. And this shows, here you can see Tran 6. That matches up with this right here. And that shows you what file has the data groups here. And it keeps 3 data groups. So the last 3 simulations you ran are here. And if you need to, you can come back in here and set one of the previous ones to be the current group. And then when you're probing on the circuit, that's the data it will use to display here. And then also if you don't want one of these last ones to disappear, you can say keep group, and then that will keep it and not recycle it. Actually, the path it was showing in the data groups page was just the path of the main simulation file, and it was just showing that as the name of the data group. So to see where the data is actually stored, I think you go to Options and General, and over here if you look in File Locations, this shows where all the different files are. So this temp data, I believe, this is where the actual large data files would be stored for the simulation, and those can be very large, in the many gigabytes if you start doing a lot of Monte Carlo runs on big schematics. Now another thing they have on here that's kind of nifty is their F11 window, which you just press the F11 key, or you go over here, Simulator, open F11 window. And that down here is just a little text area, and this, with this you can just inject piecewise straight on top of the netlist. So if you want to define some variables or add a model or something like that, you can just type in here and it'll throw it right on top. So let's parameterize one of these resistors here just for kicks. So you do just like you would in piecewise.param, and then we can call this R3 value, and we'll make it 3K. Now if we go up here, instead of here we can put the squiggly brackets and put R3 value. And if we run this again, you'll see that it added that variable 3k, passed it through here as the value to R3. So now let's add another component to our model. We can get an op amp, and we can make a little more room here. And this one has a more complicated model. So you can double click on it and then you can choose which model you want from all these different models. So we can do like maybe an op 27 or something. And if we do that, we can right click on it and we can say view edit model. That brings up this window. It's off the page a little bit here, but you can see you have two copies of the model here. So this is the SPICE model, and the top one is the global copy, and then the bottom one here is the local copy. It just copied the global part. So if you want, you can use the local model and you can just type in changes you want to make into here, and then you have your own local model for each component. So you can change the piecewise model individually for each part that you place. So we can add some parts here to this op amp. We can add another resistor, and we can add, let's put that up here. We can add a capacitor, so we can have the capacitor charge and watch the op amp switch. Now here's a little trick you can do if you want to just auto reassign all your reference designators. You can do edit, assign references by position, and then it will just go top to bottom, left to right, put them all in order. So now we can rename these probes here. Let's call this one VN plus. We'll copy it, we'll put it down here. VN minus, you have to do it in this box in here. You can't just change the label here. That won't show up. So we can put this one on the output. V out. So now we can make this capacitor a little bit bigger so that it has some time to charge. And the other thing we have to do is set an initial condition right here. So initial voltage 0. Otherwise it will just start off solving the circuit with everything balanced, and it'll set this to be fully charged already. Now we can make this power supply a little higher because the op amp's got some headroom, and then we can run it. And we see here as the positive blue, negative green. So we have the positive above the negative at the beginning, so the op amp should be high. And then when they cross over, then the op amp goes low. And you'll notice that these guys are kind of tracking each other here, which is a little bit odd looking at first, but that's because this model here has back-to-back diodes. So if you look at the model here, see here's these D1, D2 going back to back from between nodes 1 and 2, which are up here. These are the inputs to the op amp. So that keeps the inputs from going too far from each other. Now there are a couple features I'll just mention real quick. Monte Carlo and Multistep, which you can get to. There's a Monte Carlo menu here, but in SIMPLIS you can go into the choose analysis, and here you have enable Monte Carlo and multi-step analysis here, and you have that for different types of analyses, so that's how you do that. So now let's switch to SIMPLIS. So we go Simulator, switch to SIMPLIS mode, and it will automatically convert everything that it can over to the SIMPLIS piecewise linear models. But it's saying that this op-amp here doesn't have a piecewise linear model, so it's highlighting that. So what we'll have to do is delete this op-amp, but we can go up here now to place. These menus are similar, but they're new now. And we can go to analog functions, and we can just use this parameterized op-amp. And this one's interesting because you can double click on it and you can actually give it all of these parameters that you can get from the data sheet. So it's really easy to make up any kind of op-amp if you have the data sheet. And now we can run this. First we can do choose analysis and see, we can set it up here. The menus are different now. There's pop, AC, and transient. So we want a transient, we'll just leave it at 1 millisecond. And we'll click OK. And now let's run it. So it gave this error, which you can't see because it's behind my picture. But here it is. So it's saying that there's a problem with R13 value. And the reason for that is because SIMEtrix and SIMPLIS use different terms for their parameters. So they, instead of param, use var in SIMPLIS. So if we change that, we can run it again. And now we get our output. And we can see on this one that it actually looks quite different. The green negative and the blue positive don't track each other. They don't have the back-to-back diodes. And we actually get more of an idealized output too. It starts off high and it goes low. Now one thing you will notice is that the output doesn't swing quite as far as you'd think it would. See, it's starting at 5 volts. So there are some little tricks to some of these things. If you open this up, you'll notice that it has this output source, max output source current, 5 milli. And it has max output sink current, 5 milli too. So that's really small. So if we make this 50 on both of these, we can rerun it. If we just close this, it will make a whole new one. Now we see it starting up more at 15, going down to 0. So you always have to keep an eye on what these models are doing. A couple other things that have tripped me up before are this output AC resistance, this regular output resistance, 100 ohms, and then these headrooms here. So SIMPLIS has the multi-step and the Monte Carlo as well. So they are in a different spot though. They're not under the analysis section. You would go to setup multi-step or run multi-step here. And then there's this whole tab for the Monte Carlo where you can set up the Monte Carlo and run. You just tell it how many cycles you want to run and then how many cores you want to use on your processor. So it can do the multi-step and the Monte Carlo using one simulation per core. I'll go over those in more detail in another video. I'm just doing a brief overview. So another thing that this SIMPLIS has is this pop analysis. I'll have to do a whole video on that too, but that's the periodic operating point, and what that does is allows you to do a sort of an AC analysis in the time domain on a switching circuit by just repeatedly simulating a single switching cycle. So another thing you can do when you start getting a lot of parts is you can put things into subcircuits to sort of declutter your schematic. I'll probably do another video on that. And then the last thing I wanted to talk about was the scripting system. The first part of the scripting system is this command shell here, which actually my image is covering, so I'll put it on the other side. And you can write the scripting commands directly into here and it'll execute them instantly, or you can go up here to New Script, and this will make a script file here, and then you can type the script in the file and then you can run it just by clicking this play button. So you can use the scripts for a lot of things, automating repetitive tasks, but it is sort of their own scripting language. So to use it, you really need to go here to Help in the PDF manuals, and you need to get this script reference manual to figure out how to write anything with it. But I'll just show you one quick thing you can do. You can do select prop ref, and then you could say R1, and that selects R1. See, it turned it blue. And then if you want to give it a new value, you just type prop and then the property name, which is value, and then we can set it to 3K. Now it's a 3K resistor. And that brings up another point. All of these parts have properties, so if you right click on them, you can go Edit, Add Properties, and this shows you all the properties attached to that symbol. Now the last thing I want to mention is some learning resources. So you have the Help menu right here, which is actually really great. There's a lot of links right here, and these manuals pretty much cover most of the stuff. And then also you can go back to their website, and they have just on the main page, you can go to documentation, and here you'll see all of the latest versions of those manuals here as well, and then they have all kinds of tutorials and stuff you can watch here. So I might put some links in the description too of a couple that have helped me. So thanks for watching.